Hello everyone, ASGF, lesson number 5 on slopes of parallel and perpendicular lines. 3 objectives: you will be able to determine if two lines are parallel, perpendicular, or neither by examining their slopes. You will be able to determine if a shape is a rectangle, parallelogram, or trapezoid based on the slopes of the opposite sides of said quadrilateral, and you will be able to identify a missing point in order to produce two parallel or perpendicular lines. Okay, let's go ahead and get started. Okay guys, let's start with slopes of parallel lines. So two lines are parallel. Let's say here line 1 and line 2. Two lines are parallel in a coordinate plane if and only if their slopes are equal. So geometrically what that means is that line 1 and line 2, if they were to travel infinitely in both directions, would never intersect. Okay, so a symbol that we use for parallel is little arrows, just like that. Okay, we can use one arrow, we can use two arrows, depending on how large the diagram might be that you would see. Now, it's very important to understand that the slopes are equal, but the lines are distinct. So two lines could have the same slope and actually contain all the same coordinates. So it could be one line right on top of another. So let's go ahead and do an example here where we're going to find the slope of two different line segments and see if they are parallel. So it looks like here we've got segment AB and segment CD. We want to know, are they parallel if A is this point, -3, -1, B is 1, 1, C is -2, 3, and D is 0, 4. So what I'm going to do is I'm going to find the slope first of AB. Slope of segment AB. Let's do a little work with that. So in order to find slope, as we know, we're going to take y minus y over x minus x. So I'm going to take the y value from B minus the y value from A over the x value from B minus the x value from A. So it looks like the slope of this line, or line segment, excuse me, would be 2 over 4, which is equivalent to 1/2. Okay, let's look at the slope of CD. Using similar methods, I'm going to take the y value of D minus the y value of C over the y value of D, the x value of D minus the x value of C. We get 1 over a positive 2, which is 1/2. We can say since the slope of AB is equal to the slope of CD, then segment AB is parallel to segment CD. Now, a symbol that we use for parallel is that symbol right there. Okay, so since their slopes are equal, the segments are parallel. All right, let's move on to slopes of perpendicular lines. So here we have the perpendicular slope property. In a coordinate plane, two lines are perpendicular if and only if their slopes are opposite reciprocals. So first let's look at two line segments let's call one of them line segment AB, and the other, oops, I want to put a little, there we go, nice. And the other, let's call CD. All right, if those two line segments are perpendicular, then their slopes are opposite reciprocals. First, what I want to do is I want to use the symbol for perpendicular here, which is a little square in the corner. That would represent, just like we had arrows on parallel lines, we're going to use that little square at the intersection of the two segments in order to show symbolically that they are perpendicular. Now, we would say in this case that AB and CD are perpendicular, and the symbol we'd use for perpendicular is an upside down T. Okay, that symbol means those two segments are perpendicular. So let's talk about what opposite reciprocal means. So opposite reciprocal means two numbers are, well, first of all, opposite if one is positive and the other is negative. So if the two slopes have opposite sign and they are reciprocals, which means if the numerator and denominators are flipped. So an example of opposite reciprocals, let's say slope number 1 equals 2. Slope number 2 would have to be negative. Since the first one is positive, the second has to be negative, and it's reciprocal. So the reciprocal of 2 over 1 is 1 over 2. And the opposite of positive 2 is a negative, in this case, 1/2. So there's one example. Here's a second example. If slope number 1, or the slope of the first line or line segment, was, let's say, 0.75, which of course as a fraction is 3/4. In order for the two lines to be perpendicular, we would have to have the opposite sign and the reciprocal. So those two slopes would also represent opposite reciprocals. Let's look at a couple of examples below. Find the opposite reciprocal of each of the following numbers. So the opposite reciprocal of 2 over 5 is a negative 5 over 2, which can be disguised at times as a decimal, negative 2.5. Okay, the opposite reciprocal of negative 3/2 is a positive 2/3. The opposite reciprocal of 1/9 is negative 9. And the opposite reciprocal of negative 7 is a positive 1/7. Now you can start to get used to that idea of an opposite reciprocal. Let's look at a few more examples with perpendicular slopes. Okay, I've got a 3-column chart here with an original slope. I want to write a parallel slope to that original slope and a perpendicular slope to the original slope. So any slope that's parallel to an original will be the same. So the column number 2 should be very simple. We're just repeating our values. Okay, the perpendicular slopes will be opposite reciprocals of the original slope. Therefore, I would have negative 3 over 1 or negative 3. The second would be a positive 6/5 or 1.2. The third would be a negative 1. Since 1 is also 1 as its reciprocal, we would just change the sign. And the fourth one is very unique. If I had a slope of 0, that would be a horizontal line. So line 1 has a slope equal to 0. So line 2, it's perpendicular, will be perpendicular if its slope is undefined. So in the fourth case, a perpendicular slope to 0 would be an undefined slope, or a line that has an undefined slope, vertical line. Okay, let's look at some examples on the next slide. Okay, example, given that r is negative 2, 3, s is 1, 1, t is negative 3, negative 1, and v is negative 1, 2, are the segments rs and tv parallel, perpendicular, or neither? So we need to discuss real quick this idea of neither. So if the slopes are not the same, then the segments aren't parallel. If the slopes are not opposite reciprocals, then the segments are not perpendicular. And if the slopes are neither the same nor opposite reciprocals, then the line segments will be neither parallel nor perpendicular. So let's do a little slope work here. Let's find the slope of RS. Slope of RS. So I'm going to take the y values, 1 minus a 3, divided by the x values, 1 minus a negative 2. I get a negative 2 over a positive 3. Can't reduce that. We're going to leave it just like that. Slope of TV. Slope of TV will be y value minus y value over x value minus x value. That'll be a positive 3 over a positive 2. So my two slopes that I'm considering, I'm going to call this slope number 1, negative 2/3. Slope number 2 is a positive 3/2. Well, these slopes are not the same, therefore not parallel. These slopes are opposite reciprocals. Therefore, RS is perpendicular to TV. Outstanding. Let's do another example. All right, given that A is the point negative 3, 2, B is the point 1, 5, and C is the point 7, negative 3, find a point D. We're going to find an x value and a y value such that BC is parallel to AD. Okay, so I want BC to be parallel to AD. Thus, I have to find the slope of BC first. Slope of BC. Let's do a little work to find that. So y value minus y value. That'll be negative 3 minus 5 over 7 minus 1. So I'm going to get a negative 8 divided by a positive 6, which will reduce to negative 4/3. So the slope of BC is negative 4/3. I want, if these two are to be parallel, I want for the slope of AD, I want that to be equal to negative 4/3 as well. Okay, thus that would make AD and BC parallel. So the slope of AD, let's write that out generically, all right, utilizing these 2 points. Unknown point D and A, which is negative 3, 2. So if I took y minus, let's see, what would that be? 2 over x minus a negative 3. I want for that to equal negative 4/3. Okay, so how could I make that happen? Well, in this way, all that you want to consider is that I want y minus 2 to equal negative 4, and I want x minus a negative 3, which is the same as x plus 3 to equal 3. And then I'm going to go ahead and just solve for x and for y. So it looks like y would have to equal, what would that be now? Add 2 to both sides, that would be a negative 2. And if I subtract 3 from both sides, I would want x to equal 0. Therefore, the point D should equal 0, -2, thus making BC parallel to AD. All right, there you have it. Let's look at one more example for today's notes. Okay, we want to do the following. Decide if the quadrilateral JKLM is a parallelogram, a rectangle, or a trapezoid. So first we need to look at this idea of what a parallelogram really is. Okay, so a parallelogram is interesting in the way that its opposite sides are parallel. Okay. However, each of its angles is not a right angle. So what we want is two pair of parallel sides. That's for a parallelogram. A rectangle is somewhat similar. Okay, so a rectangle, what we would have, ooh, that's kind of ugly. We'll go with it, is opposite sides parallel, as well as each of its vertices forms a 90. Therefore, I want two pair of parallel sides and 4 90-degree angles. Now, the 90-degree angles will require the consecutive sides to have slopes that are opposite reciprocals. For example, if the slope here was 1/2, the slope on the opposite side would also have to be 1/2. Along with the fact that, how about -1/2? That'll match the figure a little bit better. Then the slopes of the consecutive sides would have to be a +2. This would ensure that each of the corners would form a 90-degree angle. Whereas with a parallelogram, let's say we had a slope of 1/2, +1/2 on the opposite sides. And in this case, maybe a slope of +3 on the consecutive sides. That would ensure that each of the corners is not a 90 because these two consecutive slopes in any consecutive sides would not be opposite reciprocals. Okay, so that's the difference between rectangle and parallelogram. Now, with a trapezoid only has one pair of parallel sides. So, for example, these two sides here would be parallel. So let's say the slope of this side is 0 and the slope of this side is 0. This would be a parallelogram provided that the slopes that are consecutive, let's say 2, and the slope here is -1. Okay, you can see that we have one pair of parallel sides for a trapezoid. This opposite pair here would not match. Okay, now is it possible for there to be a 90-degree angle somewhere in there? Absolutely. But with a trapezoid, we're just looking for one pair of parallel sides. I'm going to abbreviate. Okay, so let's justify algebraically whether JKLM is a parallelogram, a rectangle, or a trapezoid. The first thing I'm going to do is just graph. So J is the point 0, 2. Okay, I'm going to go 0, 2. This is J. 0, 2. There we go. K is 2, 6. L is 3, 2. And M is 2, 0. Okay, so if I were to connect this to make a quadrilateral, At least from looking at it, I'm pretty sure it's not a parallelogram or a rectangle, but I can't just say, oh, it's a trapezoid, I'm going with it, I'm good. The reason why is because I have to check and justify this algebraically. This is what this will mean here. Let's do the math. So the slope of JK, I'm going to put an M here for slope of JK, slope of KL, slope of LM, and slope of MJ. I'm going to do each in a different color just to keep this straight. Okay, so the slope of JK would be the slope of this side right here. I'm going to take the y's, 6 minus 2, divide by the x's, 2 minus 0. It looks like the slope here comes out to be 4 over 2, which is 2. Okay, let's go from K to L. K to L would be this segment here. Looks like that should be a negative slope. Let's figure that out. Y values, 6 minus 2 over 2 minus 3 comes out to be 4 over negative 1, which is negative 4. So right now, because 2 and negative 4 are not opposite reciprocals, I know that this angle will not be a right angle. Okay, so at that point, we can cross off rectangle from our possibilities. Okay, I already kind of knew that by looking at the graph, but now I can for sure know that based on the algebra. Okay, let's look at LM. LM will be the segment from here to here. We find the slope, so that'll be 2 minus 0 over 3 minus 2. That comes out to be 2 over 1, which is 2. Notice that these two slopes match. They are across from each other. Therefore, we know that JK is parallel, oops, that's perpendicular, is parallel to LM. Okay, let's see. We still cannot eliminate the idea of parallelogram. Now, as I look at MJ, I'm fairly certain that it's not parallel to KL, but I have to confirm it. So let's confirm it, and then we can eliminate parallelogram. I have a suspicion, though, that this will end up being a trapezoid. So I'm going to take the points of J, y value minus the y value of M, over x value of J minus x value of M. And it looks like I get a negative 1 for my slope. I can see that negative 4 and negative 1 do not match up. Therefore, the green and yellow sides are not parallel. So at this point, I've identified that I have one pair of parallel sides. JK is parallel to LM, and therefore I can eliminate parallelogram, and I can go with the fact that JKLM is a trapezoid. All right, guys, that is it for lesson number 5. We will see you in the next video.